Hello and welcome to Mr. Wiley Teaches Math. Today we're going to talk about polygons. First thing we need to know is the different names of the polygons. Smallest polygon, which is a closed figure, is a three-sided figure. We know that to be a triangle. Polygon with four sides is a quadrilateral. In a quadrilateral, there's many different types. We have squares, rectangles, trapezoids, parallelograms. A five-sided figure is a pentagon. Six-sided figure is a hexagon. Seven-sided figure is a heptagon. Eight-sided figure is an octagon. A nine-sided figure is a nonagon. 10-sided figure is a decagon. Its 11-sided figure is a hen, decagon. And a 12-sided figure is a dudecagon. So 3 is the smallest we can have and actually close it in. And we could keep going beyond 12, but that's as far as we can go. In some of these, you might see a relationship between the months of the year: October, November, December, 8th month, 9th month, and 10th month. Except that after they were named that way, Julius and Augustus came along and put their own months, July and August, before that, throwing off the count. Of all these different types of polygons, they can be divided into two main types: regular, irregular. A regular polygon has sides that are all the same length and angles that are all the same. In this case, my square is regular, every side is the same length, and every angle is 90 degrees. Again, I have a quadrilateral, a four-sided figure, but in this case, none of the angles are the same, and none of the sides are the same length. It's an irregular, but only one would have had to be different. I would only had to have one side and one angle that were different to make it irregular. I also have an irregular shape down here. Let's find out what it is first by counting the number of sides. Got 1, 2, 3, 4, 5, 6 sides. So it's a hexagon. So I have an irregular hexagon. Now if I want to know how many degrees are inside this irregular hexagon, there's a few ways I could do it. I could get my protractor out and measure each angle, and that would do it just fine, and add them all together and get the total. Or there's another way we can do it with using triangles. Know that every triangle has 180 degrees. We're going to use that fact to figure out the inside of this figure. We're going to pick a corner, any corner, doesn't matter this one. I'll just choose one. And I'm going to connect it to make three-sided figures, triangles, radiating out from this point. Now my lines aren't going to cross. I'm going to keep radiating out. Until I have all the triangles I can make. So I've got one triangle here, 2, 3, 4 triangles. Okay, so if I have 180 degrees inside each of these triangles, and I have 4 of them, if I multiply it together, 4 times 0 is 0, 4 times 8 is 32, 4 plus 3 is 7, 720 degrees. So inside my six-sided hexagon, 720 degrees interior angles. So that works for any shape as long as you can draw triangles out from it like this. Another thing you might notice is that when I drew on the triangles, I ended up with 4 of them. It was a six-sided shape, so it's the six-sided shape, and I ended up with 4 triangles. So if I subtract 2, it's going to give me the number of triangles, and that works in any case. Let's try it up here on my irregular here. Make a couple triangles. I think I only end up with 1, 2. My original shape had 1, 2, 3, 4 sides. 4 sides, subtract 2, gives me 2 triangles. And I could quickly find out that 180 degrees times 2 is 360 degrees. So inside this shape is 360 degrees. Thanks for watching. Be sure to check the class website for additional examples and the assignment.